look at section.
I don't think we're ready.
5.4. And notice we're going to deal with these identities on the top of page 225, where the sign of the sum is the sine A, cosine B, cosine A, sine B, and then the sign of the difference is sine A, cosine B, those identities. And then they should be on that sheet of paper, right?
Yeah.
Have you got them found? And then the tangent of the sum is there at the bottom, page 225. The tangent of difference. So those are the ones we're going to be dealing with. All right, so let's look on page 229. In the first one, so we have, they say, match each expression in column 1 with its value in column 2. And what you do is, for the sign, can you write this thing as the sum of two angles that you are familiar with so that you can know the values of them?
45 minus 30?
That's right. So you do the sine of 45 degrees minus 30. Now that identity was what? You look back at the identity for the sign of a difference, and it says it's the sine of the first one, cosine of the second, and then it's minus the cosine of the first, sine of the second. And then what's the sine of 45?
Oh, because sine of minus 1.
Square root of 2 over 2. Okay, what do you see what we're doing, Brad?
Yeah, sine A minus B.
Yeah, so this is A minus B.
So sine, cosine, sine.
Yeah.
Okay.
Then the cosine of 30 is what? Square root of 3 over 2. Cosine of 45 is square root of 2 over 2. And the sine of 30 is. So now what you have is product here, you can write it under a single radical, right? 6 over 4 minus square root of 2 over 4. So the answer is A. Okay. I think it's worthwhile to do every one of these things. So the second one.
Can you go back to that for a second? You said it was A?
Wouldn't it be minus?
Yes, yeah, it's C.
C.
Okay.
Yeah.
All right. I was taking Roger's word for it.
Come on, Roger.
Oh, yeah.
Come on, Roger. Your word is disrespected right now.
Yeah, I must have had something like that.
Yeah, yeah. Better clean your eye. Take them out, clean them.
Okay, number 2, sine 105.
So what are you going to do there?
This is like 60.
Okay.
60 minus 45
All
or
right.
no, plus 45.
60 plus
Plus
40.
45.
See, these ain't so bad, are they? So then this is the sine of 60, cosine 45, plus cosine 60, sine 45.
Is it like always like 15 like?
They're gonna make them so that they work out.
Okay. Yeah, you gotta use your 30, 45, 60. Yeah. Or
So when you go sine of 60, what do you got? Square root of 3 over 2 Remember I told you a long time ago, you gotta memorize all this stuff, otherwise
Dan did.
cosine of 45 is
Square root of 2,
square root of 2 over 2. Cosine 60 is 1/2,
1/2.
1/2,
and sine of 45,
square root of 2.
so now this one, Roger, what do you think the answer is here?
Right.
This is Roger's A. Huh?
The only one I
It
got.
was.
The only one I got.
So on tangent 15, what are you going to do?
Dan is 15, 45 minus.
Yeah. Tangent 15 is going to be tangent of 45.
Minus 30.
So then you have to look back at that identity for tangent, right? Tangent of a difference. Okay. 45 is tangent of 30.
A minus B equals to 1.8 times B. Boy.
So this one is going to be, this is 1, right? That's 1 minus, okay,
1 minus square root of 3 over 1 plus.
is that the square root of 3 over 3?
Times 30.
Okay.
Isn't it?
Yep. So now we have to get common denominator. So the numerator, it's 3 plus square root of 3 over 3. And the denominator is 3. This is minus, not plus.
Top one's minus
3 plus the square root of 3 over 3. So then this is going to be 3 minus the square root of 3 over 3 plus the square root of 3. Now you got to rationalize that denominator, and what do you multiply it by? 3 minus the square root of 3, right?
over 3 over 9 plus.
So then you have the numerator, you're going to have to expand that thing out, right? So that's going to be 9 minus 2 square root of 3 plus 3. And the denominator is 9 minus 3. Isn't that right? It's the first term squared.
To get the common.
Yeah, minus the second term squared. So then this is 6 minus 2 square root of 3. Did I do? Oh, it's 12. You're right. 12. And that's 6, right?
Why did we?
Where are you at?
Back up right there. That part? Yeah. 3 minus square root of 3, where do we get that?
What it is you have to get this radical out of the denominator.
Oh,
And it's
yeah.
a plus b times a minus b.
Yeah.
It's the square's the first, square's the second.
How did you get rid of the 3 in that previous set? Like
Oh, I inverted
oh,
and multiplied. That's why this stayed in the denominator, because this inverts, then the 3's go out.
Turns into 9. Oh.
See, this is 3 minus the square root of 3 over 3, and then this becomes 3 over 3 plus the square root of 3, because you invert that denominator and multiply.
Oh.
And then that cancels.
okay.
Yeah, invert.
And then this thing, you have to rationalize the denominator and you multiply it by 3 minus the square root of 3. It's that principle of a plus b times a minus b. It's a squared minus b squared.
Oh, yeah.
And so why did we do the 3 second part?
This one right here, because we do not want this radical in the denominator.
Geez. So wouldn't it be, why did,
See that when you do when you conjugate this, that's when I change this plus to a minus and have this binomial, that's conjugating it.
remember the formula A minus
Or if you think of it as when you factor a squared minus b squared, it's a plus b, a minus b. So when you multiply the two, you get.
Oh, so you gotta multiply it by,
And whenever you're trying to rationalize a binomial in the denominator, one of the terms to get rid of a square root, you always multiply it by its conjugate.
subtract it. So you're multiplying it by a negative just to get it out
Yeah.
of it.
This is called a conjugate of that one,
Right.
binomial conjugate.
So that's what gets rid of the bot,
Then there's no middle term when you go a binomial sum times a binomial difference. The middle term goes away, and then it's the square of the two. Yeah, it's the first term squared minus the second term squared.
Which one is the answer?
Well,
Not really
well,
that. Maybe
I
all wrong with it.
I think that probably you'd go 12 over 6 minus 2, 6, square root of 3. I'm not sure what they, yeah. 1/3 square root of 3. Or 2 minus square root of 3 over 3. There is no answer like that, is it?
No.
Is this,
32 minus 2.
what did we do wrong?
That'd be wrong.
Okay, where did we go wrong?
It's in this here.
Yes, it is. I'm busy waiting.
Well, the tangent of we got this thing right, didn't we? This is the sine of 30 degrees is 1/2, and the cosine is the square root of 3 over 2.
Oh,
And that works out right, because that's 1 over the square root of 3, right?
yeah.
And that's the square root of 3 over 3. We did that right. Hmm.
Wait. Is it like back down in the red?
Want me to go back down?
Yeah, I think like when you foil this, you have like minus 2 square root of 3. That'd be like minus 6 square root of 3.
Yeah.
And then 6 is cancel out, so you give them that.
No.
Oh,
This has got to be that term times that.
Come on top.
Instead of the 2.
Where you doing?
Like you got 3 times 3 is 9, then you got like that middle section. Then you got like 3 times the negative
This is
square root
This
of
is
3.
a minus b, the quantity squared, so it should be the first term squared, 2 times the product. Okay, there it is. You're
Yeah,
right.
see? Yeah.
3 times. There, you're so smart. So this should be 6.
Yeah.
This should be 6. Now then we got 2. 1. That was our error right there. Good job.
Should be minus 6. Oh.
Yeah.
2 minus the square root of 3.
The E.
Yeah, 6. Okay.
Good man.
Good one.
All right.
Not a
So the rest of that stuff,
You're all foiled out, bro.
let's do like number 10. Use identities to find each exact value. It's going to be similar to what we did here. Tangent of 5 pi over 12. Okay, now, being we're doing sum and difference, what is there a sum or a difference that gets 5 pi over 12?
Huh?
Well, this is, I think it's pi over 4 plus pi over 6.
Oh yeah, the alligator.
See this, if you go common denominator with 12, this has to be 3 pi over 12, and this got to be 2 pi over 12, and the sum there is 5 pi over 12.
Oh, we gotta break it down to the ones that'll fit on the wheel.
One, you have to break it down to values here that you know the value
That'll
of.
fit on our angle.
Mm-hmm. So now the tangent or the sum, this is going to be tangent of the pi over 4. It's plus tangent of pi over 6, right?
Oh, yeah.
And then it's 1 minus, isn't it? Tangent of pi over 4, tangent of pi over 6. And the pi over 4 is what? It's 1, isn't it? So that's 1. Pi over 6. Is that going to be the square root of 3 over, it's the same as 30 degrees, right? Square root of 3 over 3. Yep, thanks, Christian. Then this is 1 minus, and that's 1. And then this is the square root of 3 over 3, isn't it? So then we get the common denominator. So this is going to be 3 plus the square root of 3 over 3. And the denominator is going to be 3 minus the square root of 3 over 3. This is the same thing almost that we did before, right? 3 plus the square root of 3 over 3 minus the square root of 3. Because we invert that thing, multiply, and the 3's go out.
Mhm.
And then we're going to do what? What are we going to multiply this by?
3 minus 3?
3 plus square root of 3.
3 minus.
No, because, see, there's a 3 minus down there. We have to multiply it by 3 plus.
Okay. How do we get this? Why did we just take out the?
Because you cannot divide because these are added.
Oh,
If
you
those were
already-
multiplied, then you could cancel. That's what I'm thinking you're thinking, aren't you?
Oh, you already inverted, so, okay, yeah. And so 3 plus.
So now that numerator is going to be 9 plus 2 times 3 square root of 3. Right, Brody?
Yeah.
Plus 3. And then the denominator is 9 minus 3. Or remember I told you that when you got squared terms and it's a binomial sum, it's always the first term squared 2 times the product of the first times the second term squared. Because you're doing this to do FOILing, it just takes too much time. 12 plus 6 square root of 3, and then it's over 6. So here is 2 plus square root of 3. All right. 12 says the sine of pi over 12. So what are you going to write there? It's What do we have back here? This one was 3 pi over 12, and this is 2 pi over 12. So what are you going to do here?
Just be, I don't know.
Is it a sign of a difference? It's a sign of a difference, isn't it? See, this is the sign of pi over 4 minus pi over 6. You see what I'm telling you is this one was 3 pi over 12, and this is 2 pi over 12. When you sum them, you get 5. When you take a difference, you get pi over 12, right?
Ah. Well,
So now we're going to do, what's the identity here? Sine of the first, cosine of the first, cosine of the second. How about that? And then it's minus, isn't it? Cosine of the first, sine of the second. So sine of pi over 4 is square root of 2 over 2. And the cosine of pi over 6 is square root of 3 over 2, is it? Minus cosine of pi over 4 is square root of 2 over 2. Sine of pi over 6 is 1/2. So now we got a common denominator of 4, right? We got the square root of 6 minus the square root of 2. And that would be our answer there. All right.
what was the answer now?
Oh,
So would it be? Oh. Yeah, got it.
so 18 is tangent 80 minus tangent of minus 55. 1 plus tangent now what you want to do is look at your identities for tangent, and notice it says this thing fits into tangent A minus tangent B, right?
Yeah, it's different.
And so the difference, and if you had the difference, see when you take the difference of 80 minus a minus 55, is that a familiar angle? That's a familiar angle, right?
Why is the 55 in parentheses?
Because
Oh,
because
you
you
know.
because we're going to do a tangent of difference.
That minus
80 minus a minus 55. So that's going to be tangent of 135. And that's going to be what? -1, right? Okay. So that's a pretty easy one, right?
Whoa.
Did you get it?
Isn't there a bottom part to it though?
No.
The whole thing is the same thing as saying tangent of 80 degrees.
How did you?
See this thing is, this is tangent A minus tangent B
Got that right.
over 1 plus tangent A tangent B. Now, if you look at that particular thing and look at your identity and you look backwards on it, when you have something that looks like this, it's equal to the tangent of A minus B. In your identity things, you're going to right to left. On your identities, you're going right to left.
Yeah, so it's equal to that, then we can do minus B. So, got it.
So 20 says sine of 100 cosine of 10 minus the cosine of 100 sine of 10. So what is this? It's a sine of this thing is this thing is the sine of A cosine of B minus a cosine of A sine of B. And that's equal to the sine of A minus B. So then what you do is you go cosine of sine. You go sine of A is 100 minus 10. And that's a familiar angle, right? Which is 1. No, 1. 1 squared, I guess it could be 1 cubed. Now, the next group says use identities to write the expression as a single function. So 25, what they're asking to do now, this is actually from the last chapter. Cosine of a last chapter, the last section. When you do the cosine of a sum, what is it? See, the cosine of a sum
Cosine, sum
is the cosine A, cosine B, sine A.
so that
Sine A. Yeah. I'm not sure why, but that's what it is. So it's cosine 60 plus times cosine theta minus sine 60 sine theta. So what's this thing?
This is the sum of the cosine.
Yeah.
Cosine equals
Cosine 60 is what? 1/2?
1/2. Plus theta.
Square root of 3/2. So you got cosine theta minus square root of 3 sine theta over 2. What? What did I do?
Huh? 1 minus the square root of 3 equals minus square root of 3. Oh,
I'm not 100% what they want in
they
the
want to solve that. You're going to come up with the same answer, but with the cosine.
That's what I did. Now you could do it this way. The cofunction of 90
All the old AI.
minus the 60 degrees plus theta. Then it's in a single, this is in a single one. So this would be the sine, no, see this is 90 degrees minus 60 degrees minus theta.
Am I?
That's a single function. But I,
To do it the second way.
they actually do it this way. I think it's poorly stated, probably.
Why is
Because it says, write each expression as a single function, and I guess what they're saying is that they wanted not to have a sum or a difference.
what happened to the one?
This seems to me like it's a single function, but
Multiply it by cosine to square root.
but this is what they're asking you to do. So I'm going to ask you to do one problem like this. So when you do it this way. It'll have the same kind of explanation, right? As a single function. Do it this way. It'll be like not a sum or a difference. See, like this is a difference, but it seems to me like it's a single function. But I don't know. This is a single function, so they're saying write it as a single function, so they must be saying write it so that you're not writing it as a sum or a difference of angles. That's what I'm guessing. On 230, then they're saying find the sine of the sum, the tangent of the sum. Okay. Wow. Let's look at 44. 44 says sine. I never like it when they use S. And they're saying that S in quadrant 1, T is in quadrant 2. Okay. Now, there's whenever you have something like this that's on a test, and if you have sine is equal to 3/5 or cosine is equal to 4/5, that's a 3, 4, 5 triangle. It's always a 3, 4, 5. So sine, if either sine or cosine is equal to 3/5 or 4/5, the other one is the other. Because it's a 3, 4, 5 triangle. Yeah. So you can figure it out. You could figure it out like this. And if you did the cosine for this one, you could figure out like okay, I'm going to do cosine squared theta t plus sine squared t equals 1, so that cosine t is going to equal, and cosine, this is in the third quadrant, right? So the cosine in the third quadrant is going to be positive. So it's going to be positive square root of 1 minus sine squared. Correct? It's negative. Thank you. No, it's positive. Yeah. The sine's negative, the cosine's positive. The cosine is the x value, the sine is the y value. You're leading me astray. So you could do the same thing here. But I'm just telling you that I would not spend the time. If I had a 3/5 or a 4/5, I would take the other one and say that it's 4/5.
Positive though, because,
And it's in quadrant 1, so it's going to be positive.
what about, quadrant 3, I don't get the cosine and sine both ways.
That's in, oh, okay, you're right. Jeez. I was thinking 4.
And I don't know how you got it. but-
I know it. I wasn't thinking. So this one, you're going to have to go 1 minus,
Plus or minus? Oh. Oh, it's minus.
no, it's minus, because that's going to tell you what to choose. Minus 12 over 13, right? Quantity squared.
Okay.
Okay. So this denominator is going to be squared, so it's going to be 13 squared minus a minus 12 squared in the numerator, right? All over 13 squared.
Oh, yeah, we do that 13 squared.
And then you said, does it come out to be 5? 13 times 13, what is that, 169? 169 minus 144. And that denominator is 13 when you take square root of it, right?
So 5 over 13?
13 squared is
Yeah.
Yeah.
Well, but I think if you take the square root of it.
Yeah.
okay.
It's 13 after you work it down.
Yeah. So then this thing is 25, right?
So 25 over
13,
5 over
which
13.
Roger said was 5/13.
Oh, Rod?
Yeah, 5.
Alright.
Yes.
I read the assignment already.
You what?
All right. All right. So now we're ready to do the plus. Remember that it said to do sine s plus t, tangent s plus t, and then what quadrant is it in? So the sine of s plus t is what? The sine of s cosine t
Yeah. Well,
plus cosine s
cosine.
and sine t. So the sine is 3/5, and the cosine was this thing down here, minus 5/13.
So,
And then the cosine was 4/5. That's minus 12/5. 12/13. Well, I'm just picking it up. Here's the cosine t. And sine and cosine, sine
yeah.
3/5, 4/5. And this is 12.
Okay.
So then the numerator here is a negative 15. We have a common denominator of 5 times 13, right? Wasn't that what we got down here? No, that was what we had up here.
Okay, I'm really confused. How did you get 5
It's a square root of the numerator and square root of the denominator. Yeah, see this radical is the square root of the whole thing. And this denominator is 13 squared. So this is going to be the square root of that, and then the square root of 13 squared, which is 13.
You didn't work that part out.
this thing comes out to be the square root of 25 over the square root of 13 squared. And then the square root of 13 squared is 13.
Follow me?
I'm pretty sure I'm right there.
Yep, no, I just missed it, so.
Okay, well, I have not got it 100% right either. And this is 5 times 13, right? I'm just leaving it that way for a bit. So is that 63? Negative 63 over 65.
Oh,
And that's the sine of the sum.
yeah, I figured.
And then the tangent of the sum, right? And that's tangent S, right? That's plus tangent, isn't it? T. Like,
So tangent plus AB.
and then this is 1 minus, isn't it?
Yep.
Tangent S, tangent. Maybe we should figure out what tangent is. The tangent on this thing is sine over cosine, so it's 3/4, isn't it? It's 3/4 over 4/3, so that's going to be 3/4, isn't it?
Okay.
3/4 over 4/5, sine over cosine, which is 3/4, isn't it?
Yeah,
3/5.
yeah, 15, 20.
And this one is what? Tangent here is going to be, that's negative 12/13, isn't it? Over a negative 5/13, which is a positive 12/5. Is that right? Then we substitute in here.
Yeah.
So this is going to be 3/4 plus 12/5, 1 minus 3/4 times 12/5. Okay, so we're going to multiply numerator denominator here by 5, right? 5 over, and then 4 over 4. And then this is 20. That's the denominator is 20 in both numerator and denominator. 20, 15 48. What 15 and 48? What did you say it was? 60.
31,
15 and 48, 63.
Oh, 12 is head by 12.
15 plus 48.
15 plus 48,
63.
20. That breaks down to
And then this is 1 minus 36 20ths. And then you have to go 20 over 20, right? 20 minus 36 is 16, right?
oh yeah, 20 over 20.
And then you invert and multiply.
Let's just leave it at 16, 20.
63 sixteenths. Is that right? Okay, now
Yeah, 63.
I gotta see where in the heck what did we do? This one, this is that numerator, and then this was that denominator. The answer is 63 sixteenths, right?
Yeah, if you split 50%.
There's no common factors, so that should be it.
Nothing goes in 63 except 3.
Okay. So I'm going to give you one of those to do because those are so much fun.
Oh, man.
You're a hell of a lot.
321 says 9.
Okay, the next one, exact value. It says find exact value by the technique, section 5.3, 51. Now this thing should be, this should be pretty familiar. What,
That's
It's gonna be over 4.
something plus
Uh,
6 plus
5
4.
is it?
6 plus a quarter.
okay, it is going to be tangent of something over 4.
5, 6 over 1.
Something pi over 4 and then pi over 6.
Yep.
But
That's it.
you see, it's going to have to be 3 pi over 4. Because then it's 9 plus 2, right?
Oh, yeah.
You're getting pretty scary. Tangent of 3 pi over 4 plus the tangent of pi over 6, right? And it's 1 minus the tangent of 3 pi over 4 tangent of pi over 6. 3 pi over 4 is going to be what? Negative 1, right? Plus this thing is old familiar one, isn't it? Square root of 3 over 3.
That's square root of 3.
Yeah.
Square root of 3 over 3. So they got 1 minus, and now that's a minus 1, right?
What?
And that's square root of 3 over 3. So we got a minus 1 plus square root of 3 over 3. Then we got a minus, or 1 plus square root of 3 over 3. So we got to get the common denominator. So this is going to be minus 3 plus the square root of 3 over 3, right? Numerator.
Okay, wait.
The numerator. Common
Oh, it's just the top part.
3 over 3. This is just the top. Now the denominator is going to be 3 plus square root of 3 over 3. So it inverts and multiplies, and we have a negative 3 plus the square root of 3 over 3 plus the square root of 3. So now what do we do to rationalize that denominator? 3 minus the square root of 3, right? Now that numerator is going to be first term squared, which is going to be a, no, we're going to FOIL it, excuse me. This is a FOIL deal. It's negative 3 times 3 is a negative 9. And then it's going to be outside terms plus 3 square root of 3. Inside is 3 square root of 3. And then the last is a negative 3. I FOILed it.
Oh, you boiled it down, okay.
Then this is, the first term squared is 9 minus the second term squared is 3. So combining terms, we got a minus 12 plus 6 square root of 3 all over 6. So it's a minus 2 plus the square root of 3.
A lot of these, yeah.
The clock's leaving, so.
What?
The clock leaving, so.
These next
Yeah.
tests take me literally like 4
Yeah,
I don't know how you got it. I get the bottom there.
well, this is A
Oh, yeah,
plus
they
B,
foil
A
out,
minus
foil
B.
in, foil out, minus 3.
Foil in, foil. I tell you, I don't understand that. I don't want to go there. Okay, the next one, 62. This is an identity. S plus E over cosine S cosine T equals tangent S plus tangent T. Just a second, I want to finish right.
Minus 2 plus 6
No,
plus
no, no.
3. Yeah, minus 12. Oh,
Minus 2.
plus square root of 3.
Yeah,
Fine. What happens at 6?
cancels. See, it's 12 over, well, look, this is what you do. You go minus 12 over 6 plus 6 square root of 3 over 6. Common denominator, then you can split it into two parts, and this is,
That'd be a minus 6 the square plus.
Well, we got my 6 is 2.
I'll see if 6 plus 6
see, this is a common denominator, so then you can put it, the 12 over it, and then you can put this term over it. That becomes 2, that becomes square root of 3.
Okay. Cancels out the 6 too also, okay.
He is. See, right here.
Okay, this is an identity.
Yeah. Can verify it.
Now,
I can't.
what I'm going to do is I'm going to take this thing here and substitute its identity, because this is already in single S and T.
Mhm.
This is in sum, and I know I'm going to want to get rid of that.
Yeah.
So the numerator is going to be what? Sine S, right? Cosine T plus cosine
S.
sine T.
Sine T. Over.
And then, now what I'm going to do is, I'm going to write, rather than, I'll do it this way. Now what I'm going to do is I'm going to put each one of these terms over there. And it's going to be plus, and I'm going to put that term over that.
And you split it.
Oh, you're just splitting that out, okay.
Now notice that this cosine T
Can't.
cancels, and that cosine S. Now we have sine over cosine, which is tangent S. You see, we're getting it, right? Tangent
Guys.
T. The trick you want to do is get rid of these sums and differences of angles. This don't have sums and differences. You know, before we said always convert it to sine over cosine. The reason we don't do that yet is you always want to get rid of your sums and differences first.
Do you have a sheet?
No, no,
Yeah.
no.
Oh, how those you? Okay, I got it.
Okay. The next section, double angle formulas.
What?
No, it isn't.
Yeah.
5 after.
7 after.
Mike,
Okay, 5 what?
his sundial here is working well inside. Notice the double angle formulas on bottom of page 233. And what you can do, what you can actually do with this is use your cosine of A plus B and go A plus A. And that's what this is. If you go cosine A plus cosine of A plus B, if you put A in both those places, cosine A plus A, and then you figure it out, it gets to be this way. You understand what I'm telling you? That's
No.
That's
but
the
let's
simple-
just keep going.
what I'm going to do. Cosine of A plus B is what?
How does it get harder?
It's cosine A, right?
Yeah.
Cosine B minus sine A, sine B, right? Now, if you substitute for this B, if you substitute A, okay, then this becomes cosine A minus sine A sine A
Cosine squared
minus sine squared A.
Where's that at?
That's cosine
2A.
2A. That's just how
Well, that's how you get the, oh,
that's how the formula came about.
that's what you were saying earlier.
Yeah.
And they little
Why does it gotta show us two different?
See, and then what you can do to get that cosine 2A is equal to 1 minus 2 sine squared, you just take this thing and substitute 1 minus sine squared in there, right? So it's going to be 1 minus 2 sine squared. Then to get that other one bottom on the left, you substitute 1 minus cosine squared here. Then that becomes 2 cosine squared A minus 1. Right? Because that minus sign will go through 1 minus cosine,
Oh,
make it a plus cosine.
yeah.
That's these are really easy to kind of.
How do we, what's cosine one?
Well, see, if the first thing you do is you substitute for this one 1 minus sine squared.
Oh, yeah. Yeah, got it.
See, then this is 2 negative 2 sine squared, right?
Yeah.
1 minus negative 2 sine squared. And then the next one is just a little bit trickier. For that one, you substitute for sine squared 1 minus cosine squared.
Oh, it shows it right there.
And what it does is that negative makes this a minus 1 and that a plus, so then you have 2 cosine squared minus 1.
2 sine squared.
It all just comes from
Cosine.
all your identities.
Oh,
And then that sine of 2A is just, you take the sine of A plus B and put, for B, put
or
A
you-
in. I mean, it's easy to justify those from what we have had before.
So it could be either one, then, right? You could put either one or not.
This is just how they derive the formulas.
So,
And then on page 238, they're doing the product to sum. And there's,
actually,
do you notice that what they're doing, they're telling you right up above there how they come about that. They took that cosine, when they took cosine of A plus B equals cosine A cosine B minus sine A sine B. And then they took cosine of A minus B. It's cosine A cosine B plus sine A. Now if you just add these straight down this way, this term drops out, right? You have 2 times this equals the sum of those two.
why are we putting those together?
And then it goes 1/2, right? See how that's how they derive that first problem. Then if you subtract the bottom one from the top one, then you'll get that second one. It's just doing sums and differences of those, and then you do the same
So
thing.
cosine 2A, coming up with that.
Say, if you add these two together, what happens to this?
So,
Goes out, right? And then what, this is gonna be 2 times that. And then this is the sum of cosine A plus B plus cosine of A minus B. And then you divide by 2 and that's 1/2 that product. That's the first of those identities on page 237. It's right above there. It's telling you how they derived them, right above there on page 237.
Oh, yeah, where in the deal?
Yep. Yep. And then there's those sum to product identities on page 238. We're going to have to utilize all of those things.
Anyway, I say
Huh?
I'm using 4 hours.
I'm probably just coming to paper.
I'll give you the columns. We just did, we put in section 5, 4.
Five, four, yeah, we need to finish five.
Right, before I forget it, I'll give you 5.
Figure it out.
Holy cow, 37 problems.
What?
Check.
73 pounds, you're.
Shelby got it?
Drew is like the people in my bio class. They put their headset on. Make little
Oh.
moves.
I put them all
They
over
learn
Ozzy.
because the lecture was on tape. And I always figured they just learned by osmosis. Because we was in biology.
Well, some of them are learn by reverse osmosis. That's it, nobody knows. That's the way that- my
I
friend-
think I actually did. Instant reading.
There wasn't a section or chapter homework, was there?
What?
Because I've got 5.1, 5.2, 5.2, 5.3, but I don't have like an overall.
I don't have one.
Right.
Just making sure.
I'm not gonna do it overall.
Okay, sounds good, thanks.
Dude, don't do that. You don't say that, Drew. That's totally not cool.
Yeah, you should probably not say
Don't
that,
say
man.
that. It's only gonna. Yeah. You will.
Lily was here.
I'm here.
That was Trevor was, Daniel was,
That's probably not fun.
Brandon was, Kristen was, Drew.
I'm
He was here
just gonna-
physically.
Right, you hit it. Hit it, dude.
You know, I actually got these things for, I can hand them back. I got one graded for you.
Oh,
Does that look graded?
well, it's got red marks all over, it, yeah. 5.1, yeah. Yeah, look at it. Oh, not bad. Still hanging in there.
I guess the only person that I got stuff for that I didn't get back is Blake. He don't care. He's only here in the body. Great stuff, isn't it? Ooh,
We're how many
Really
nanoseconds from 60 you can forget it once it's ready, but
I'll tell you what, you don't use it, you'll forget it pretty fast.
I know. It's like-
But the only thing is
like
it will, you know, if you look at it again, and, you know, it won't take you long to relearn it.
Yeah. You know,
But if you take calculus, Calc 2, you will use this stuff till you're sick.
I will not be going to school any for, at this point in time anyway.
No. That's what they all say.
Yeah, I know. At this point in time, I didn't have them delimiter here.